a double recording.
Recording in progress.
Okay, so missed the first part about changing to polar form, but there is a video. There's some work day where we did a worksheet all on complex numbers. Does anybody remember which one that was? So if you missed this first part, you can go back and find in one of the recordings on the Moodle page. It has all about complex numbers. Okay, to change to rectangular form, 3 angle 0, well, that's a real number. So that's just 3. If you wanted to write it as 3 plus 0j, or j0, you could, but it's just 3. 2 angle 90, well, now that you understand about the real axis and the complex axis, you see that 90 degrees puts you right on the imaginary axis. And so 90 degrees is purely imaginary. So this is J2, because it has length 2. 1.5 angle negative 34. So to get that one, we have to use Euler's formula. So 1.5 angle negative 34 degrees. 1.5 angle negative 34 degrees. We're going to use Euler's formula, which says that we'll take, if I have A angle theta, then that equals A open parentheses cosine theta plus J sine theta. So this one would be 1.5 open parentheses cosine negative 34 degrees plus J sine negative 34 degrees. And then 1.5 cosine negative 34 is 1.24 plus J, well, this is going to be minus when I do sine 1.5 sine negative 34, I get negative 0.84, so minus J 0.84 changes that to rectangular. Now, if this was not the problem where you had to show your work and I needed to change 1.5 angle negative 34 to rectangular, I would just do 1.5 and then go to the complex menu, angle negative 34, back to the complex menu, and change to rectangular, and I get 1.24 plus 0.84 I. So that's how you would do that. Similarly, for this last one, if it weren't on the problems where I had to show my work, I would just type that straight in to the calculator and get the answer. But for this one, I have to show the work. So you need to decide, do you want to do it in phasors or do you want to do it in rectangular? And it's probably easiest to do, addition is more easily done with rectangular, and multiplication and division is more easily done with phasors. So the first thing we'll do is change the 5 angle 20 to rectangular. So 5 angle 20 is 5 cosine 20 plus J sine 20. And I'm just going to cheat. So I've shown that that's what I would do. And rather than typing that in twice, 4.7 plus j 1.7. So that numerator becomes 4.7 plus j 1.7 over 3 minus j5. So then the numerator is 4 plus j2. So the total numerator is 4.7 plus j 3.7, and the denominator is 3 minus j5. Now, if I wanted to do this all in rectangular, I would multiply the top and bottom by the conjugate. But instead, since I have a division here, I'm going to change both of these to polar. So to change them to polar, I'll take the square root of 4.7 squared plus 3.7 squared. And I get 5.98. And then I'll take the inverse tangent of 3.7 over 4.7. And do I need to add or subtract 180 from this when I get this answer of 38.2 degrees? Is that good as it is, or do I need to add or subtract 180?
That's good.
It's good because they're both positive. So if they're both positive, you're fine. And then 3 minus j5, I'll take the square root of 3 squared plus 5 squared, and that gets me 5.83. And then I'll take the inverse tangent of negative 5 over 3. And I get negative 59 degrees. Now, do I need to add or subtract anything to that? Well, let's see. So our real part is positive, and our imaginary part is negative. So that puts us down here in quadrant 4. Quadrant 4, that's okay, because negative 59 degrees, that's where I am. So I don't actually have to do anything on this one. So I can leave it the way it is. Now that they're phasors, to get my answer, I'm going to divide the magnitudes. I'll divide 5.96 by 5.83. 5.96 divided by 5.83. And I get 1.02. And for the angles, it's going to be the numerator minus the denominator. So it'll be 38.2 minus negative 59. So 38.2 plus 59. And I get 97.2 degrees. And then, because if I were doing this on a test, I would want to check myself and see if I got the right answer. I would go back and I would do 5 angle 20 plus J2 over 3 minus J5. I have my calculator set to rectangular. I want my answer in polar, so I'll just go ahead and tell it to convert to polar right here. and I get 1.02 angle 97. Now, if this were really me on a test, what would happen is I would not get the same answer, and I would spend the next 45 minutes trying to figure out what I got wrong on this 3-point question, and then I'd look up and I'd say, oh, I have 5 minutes left to do the rest of the test. Yes?
I got 0.9. You think that's close enough for it to be count right or no? Like, and so you got 1.023, and I got 0.9. Because I guess I read it too much.
Yeah, I don't know. Did you check like your work along? Did you show your work all the way through?
Yeah.
Then you're probably okay if you showed all your work.
Okay.
Yeah, but if you just had that as an answer without any work, probably not.
Yeah.
Okay, so one last thing. What if I had done all this and I got as my final answer, say 1.02 angle 190 degrees? What would I have to do at that point?
Subtract 360.
Subtract 360, why?
Because if you just subtract 180, it's going to go to the other side, and you need it to be within 180 to negative 180.
Right, we want our angle to be between negative 180 and positive 180, and if it's not, what you need to do is add or subtract 360, not 180, because 180 would take you to the wrong quadrant, but plus or minus 360. And so this is too big, so I would subtract 360 and get the negative value. What if, let's see, would this happen? No, it would not happen. Okay, any other questions?
Unrelated, should I go check to see if that's printed yet?
Yes, while you do that, I'm going to stop this particular recording and get ready to start the next one. Any questions from online? I don't see anything in the chat.